Hello and welcome to the section on margin of error. And really, this is the one concept right here, a plus and a minus. What does that mean? Let's talk about it. This really grows out of the concept we just discussed of empirical probabilities. What happens with experiments? Let's give you an example for a minute. I flipped a coin 60 times, just recently, in fact, and I ended up getting 25 heads. I didn't know if it was a fair coin, if I was supposed to get a 50-50 or not. I ended up getting 25 heads out of 60. If I compute the empirical probability of that, that is a 41.666666 on for round to 41.7%. And I could right there say, oh my goodness, this coin isn't fair. But I flipped that exact same one again 60 times, and this time I got 32 heads. The same exact coin. And this time it produced 32 out of 60 was 53.3%. Oh my goodness. Is that weird? I mean, here we were experimenting and it's the exact same coin, and we realized that yeah, it's actually understandable that we would be off just a little bit each time we did that, just by random happenstance in experiments. I mean, this is a little bit messy when you flip a coin so many times and you do it again. You can't expect it to be the exact same thing every time. The differences between the different experiment results within a certain allowed flexibility, that's what we call the margin of error, that we expect a certain amount of error to happen. Well, when you do 60 flips of a coin, the margin of error turns out to be about 0.13, so 13%. So if this were a fair coin, we would expect this to come out at 50%. It turns out that for 60 flips, you get 13% plus or minus without any evidence that it's not a fair coin. So let's try that. 50% plus 13%. So if it were up at 63%, nobody would even care. Minus 13%, if down at 37%, that's not odd enough with only 60 flips to say, hey, something is going on wrong. You don't have a fair coin. And that's really what it is. Figuring out how you do margin of error is something that we'll do in Math 108. But for this course, you're simply expected to understand that when they give you a margin of error, a plus or minus, that's what you do with it. You say, okay, here's what we got, and it could be up that much or down that much. I'll show you how this works with real life situations. Here we have a Gallup poll, and you'll notice it says that 9% of Americans approve what Congress is doing right now. The question is, what does that mean? 9%? Well, yeah, that's pretty bad. 9% of Americans actually say Congress is doing a bad job. Well, say that they're doing a good job. But notice down here in the very bottom, can you guys read that? I'll blow it up so you can see it if you can't see it. It says MOE plus minus, there's a little dash in between them, plus or minus 4%. So what that really means is that when they took this poll, Gallup, it's a company that does statistics, they tested a bunch of Americans, called them up, said, hey, what do you think? Is Congress doing a good job or are they not? And they got an answer at 9%. Because they recognize there could be a difference next time they do this testing. It could be up 4% at 13%. Or down 4%, it could be as low as 5%. It's really somewhere in this range. So you go plus or minus 4%. Let's write it like that. And so there's the maximum, there's the minimum. And that's really what you're expected to do. Let's give you a couple of problems and see if you can work through that. Okay, to the boards. Go and try these problems on your own. Pause the video as you work through them, and then press play when you're done so that you can see how these were worked out by us. All right, welcome back. I hope you did well with that. So, example 1, a study found that the percentage of sloths hanging upside down at any time is 72%. Good deal. That's our baseline. That's what we're going to start on. So 72%, and then it says the margin of error is 8%. So MOE, margin of error right there, is equal to 8%. So that means we can go plus or minus 8%. What are the minimum and maximum values of confident estimates? Meaning confident That's whoever did this study, they know 72% might be off a little bit. They're really confident that it's within this margin of error. So that means the minimum value, 72 minus 8, gives us 64%. And the upper value, 72 plus 8, is 80%. So what they're really saying is we believe that the true value of all sloths, 64 to 80% of them, are hanging upside down at any one time. Cool. All right. In a recent election, example 2, in a recent election season, a poll had Fitzherbert at 43.2%. So Fitzherbert centers at 43.2%. And Donaldson's down here at 37.5%. Oh, look at that. It looks like Fitzherbert's winning. However, let me see the 19.3% undecided. Oh, this doesn't add up to 100%. Undecided is 19.3%. Okay, good. The poll had a margin of error of 3.5%. Oh, see, this margin of error is really informative. Who is winning? So this guy could go plus or minus 3.5%. Now, if these were all decimals, this would be 0.432 and that would be 0.035. So keep that in mind if they give them to you in decimals instead of in percent notation. Okay, so its highest one would be 46.7%. So Fitzherbert is really 46.7% to 39.7%. 39.7%. Let's rewrite that one a little bit. There we go, 39.7%. Okay, and we just took plus 3.5 and minus 3.5. Now when we go to Donaldson, let's do him in a different color. We've got to go up 3.5 and down 3.5. So up 3.5 would mean he's up at now 41%, and down 3.5 means he's at 34%. So his true percentage could run anywhere through here. Now notice the question, who is winning? Well, at first glance, it looks like Fitzherbert is definitely winning. However, you'll notice it's possible that Fitzherbert is at a 39.7 and Donaldson is a 41. This is within the margin of error. Since it's within the margin of error, it's possible that Donaldson is actually winning. So they would call this a statistical tie. That these two are not far enough apart to actually tell the difference. You'd have to do a much larger and more detailed study to get this margin of error down to a smaller percent to be able to tell if Fitzherbert or Donaldson's really winning. But right now, we don't know. Undecided kind of wins out on this one. Nobody knows yet because the margin of error is big enough that these two overlap. The minimum for Fitzherbert, the maximum for Donaldson. Yeah. All right, that should give you enough to head through on your homework.